This video will tackle Soxhlet extraction, focusing on nicotine as the target compound to be extracted. A brief history of tobacco and the Soxhlet apparatus will be presented, plus the principle of the Soxhlet extraction and some of its applications. The tobacco plant is indigenous to the Americas and has been used as a medicine and stimulant for at least 2,000 years. It is not known how tobacco first reached Europe. However, Christopher Columbus is often thought to have discovered tobacco while exploring the Americas for the first time. The smoking of pipes and cigars spread quickly throughout the 1600s. The plant divided opinion when it was introduced to Europe. Some saw tobacco as medicinal, while others saw it as toxic and habit-forming. The tobacco industry grew throughout the 1700s and exploded in 1880 when a machine was first patented to mass-produce paper cigarettes. From then on, cigarettes became much easier to produce, and this saw in the dawn of the major tobacco corporations. Additionally, tobacco was first used as an insecticide in 1763. In 1828, two Germans, Wilhelm Heinrich Posselt, a doctor, and Carl Ludwig Reimann, a chemist, first isolated nicotine from the tobacco plant and identified it as a poison. By the end of the 19th century, lawmakers had begun to realize the harmful effects of nicotine. Laws were passed banning stores from selling nicotine to minors in 26 states by the year 1890. In the Philippines, we have the Tobacco Regulation Act of 2003. It was not until 1964 that the Surgeon General of the US published a study linking smoking with heart disease and lung cancer. The US Food and Drug Administration, or FDA, took until 1994 to officially recognize nicotine as a drug that produced dependency. The structure of nicotine is shown here. Nicotine is an alkaloid found in the nightshade family of plants, predominantly in tobacco, and in lower quantities in tomato, eggplant, and in green pepper. The term alkaloid refers to any class of nitrogenous organic compounds of plant origin which have pronounced physiological effects in humans. When a body is exposed to nicotine, the individual experiences a kick. This is partly caused by nicotine stimulating the adrenal glands, which results in the release of adrenaline. Consuming nicotine is also linked to raised alertness, euphoria, and a sensation of being relaxed. All of these effects came into light because chemists and doctors know how to extract nicotine and study its effects in various conditions. How is nicotine extracted from plants? One famous method is called the Soxhlet extraction, which we will now discuss. Before proceeding to the principle of Soxhlet extraction, let's have a little go at the history of this method. It was developed by Franz von Soxhlet, a German agrochemist who was interested in studying proteins and fats found in milk. Thus, he came up with this technique of extraction in 1879. The setup consists of three major parts: the boiling flask with the extraction solvent, the Soxhlet extractor, and the reflux condenser. The boiling flask simply contains the extracting solvent. We expect that any compounds in our sample that dissolves in the solvent can be extracted. Remember the rule like dissolves like. The reflux condenser, on the other hand, is the same as the condenser that you have seen in your simple and fractional distillation setups. The difference is that the condenser in the Soxhlet apparatus is upright, which is essential to the operation of the Soxhlet. Now let's focus on the Soxhlet extractor. It has two arms attached to its main body. One of the arms is called the distillation path. It is where the vapors of the solvent pass through and arrive at the condenser. Once the vapors arrive at the condenser, it will obviously condense and fall down to the extractor. Inside the extractor, we find the thimble where the sample is placed. All compounds in the sample that can dissolve in the solvent will now dissolve in the condensed solvent that accumulated in the thimble. When its level rises above the highest point of the siphon arm, the solvent, together with the extracted compounds, will be siphoned back to the boiling flask. The process is repeated until the solvent in the boiling flask becomes enriched in the compounds that are desired to be extracted. Selection of solvent is very important in Soxhlet extraction. It depends on which compounds are to be extracted from a sample, the nature of these compounds, solubility of these compounds in the solvent, and volatility of the solvent. After Soxhlet extraction, we want to get rid of the solvent, and the easiest way to achieve this is through evaporation of the solvent. Toxicity of the solvent is also a factor. If there are residual solvent on our extracted compounds and use the extracted compounds as potential drugs, the residual solvent may pose risk. Again, the solvent can be polar or nonpolar depending on the type of compound that you want to extract. Now, what are the advantages of using Soxhlet extraction over other extraction methods? For one, this method is autonomous. Once the setup is finished, you can go and do other stuff. Second, you don't need to use a large amount of solvent because the solvent is sort of recycled. It is also easy to scale up any Soxhlet extraction. Finally, it is fairly easy to optimize Soxhlet extraction parameters, such as the choice of solvent and the length of time in running the extraction. And that's it for your lesson on Soxhlet extraction. I hope you appreciated its principles and applications, especially in the pharmaceutical industry. The following are the references used in making this video which you can access.